Okay, you're welcome to NX videos, and today I want to explain some key facts concerning periodicity and specifically the physical properties. What is their trend? We need to know some of the physical properties that we are going to explain. However, for today, I'll explain only the first one, that is the atomic radius. However, the others, and radius, ionization energies, electronegativity, those will be another time. Let's begin by understanding the definition of atomic radius. When we talk of atomic radius, we need to know that we are referring to the total distance from an atom's nucleus to the outermost orbital of electron. That's what we mean by atomic radius. But remember, it's not easy to measure it. It's not very easy. But our key point today is to know what is the trend that is across the period and then also down the group, and asking a simple question that across the period atomic radius decreases. I guess you can see this, it is decreasing. Why? There are key hints that I want to give you concerning this atomic radius. One is about the number of protons. Sodium and magnesium are both in the same period, but let's look at the number of protons. Sodium has 11 protons, magnesium has 12 protons. That means the nucleus of magnesium has a higher positive charge. That means it exerts a stronger electrostatic forces on its electrons than the sodium nucleus. That means electrons are more attracted towards the nucleus in magnesium. That is one of them. Then let's look at another reasoning so that we can get the full explanation. Look at the principal quantum numbers. This is 1, 2, 3. Then in magnesium it is also 1, 2, 3. So the principal quantum number across a period does not change. What changes? The number of protons being added in the nucleus of an atom increases, and hence there's an increase in the nuclear charge. However, the principal quantum numbers does not increase, meaning that electrons are being placed on the same principal quantum number or on the same energy level, meaning that the distance apart does not increase. Therefore, such electrons experience a stronger pull towards the nucleus since they are all being placed on the same principal quantum number. Let's look at the simple explanation I put down here. I'm saying that as you go across the period, there is addition of a single proton in the nucleus of an atom, and hence an increase in the nuclear charge because the nucleus is becoming more positive. And then also across the period, there is no increase in the principal quantum number. Therefore, the additional single electron is being placed or added on the same energy level of the same principal quantum number. Just check. Sodium, the third. Magnesium is being added on the third, though there are two now. So what does this mean? Therefore, electrons within the electron cloud will experience a stronger attraction towards the nucleus and hence a decrease in the atomic radius. That's the explanation. Then let's move down the group. If I take group 1, I'll pick just 2 atoms. I picked magnesium and I picked also potassium. Still, let's look at the protons. Always look at the protons. Sodium has 11 protons, potassium has 19 protons. That means down the group, nuclear charge increases. So we would expect a stronger attraction of the electrons towards the nucleus. That's what we would expect. But let's check what is happening also to the principal quantum numbers. In sodium, we have 1, 2, 3. Then in potassium, 1, 2, 3, 4. Although they both have a single electron, their outermost energy level, but the number of principal quantum numbers differs. You find that the inner shells in potassium contain that are full are more than the ones in sodium. So this means that the inner shells containing electrons tend to repel the outermost electron more, and hence they reduce the nuclear attraction of the outermost electrons towards the nucleus. In other words, they are shielding the outer electrons from the nuclear attraction. So what do you need to know? That down the group there's an increasing shielding effect. This shielding effect offsets or offsheds the nuclear attraction. So why does the atomic radius become big? Because of an increasing number of electrons. The inner electrons repel, or there is greater repulsion between the outer electrons and the electrons on the inner principal quantum numbers, and this leads to an increase in the atomic radius and hence an increase in the size of the electron cloud. That's why there is an increase in the atomic radius down the group. In case of any question, you can reach me or you can visit my website too. And this is my website, that is biochemistrytutor.netlify.app, or you can WhatsApp me or you can call me. But I want to remind you that the more electrons added, or the more electrons within an atom, the greater repulsion that is felt, and hence an increase in the electron cloud that determines or that increases the atomic radius. Thanks for watching Enoch's videos. Don't forget to subscribe. Goodbye.